GCSE Physics boosters, mass and weight. What is the difference between mass and weight? What do you need to know about mass and weight? Let's start with this bag of sugar. Here's a bag of sugar. Now, what is its mass? What is its weight? Well, its mass is written on it. Its mass is 1 kilogram. Okay, it's actually written on it. And the mass of something measured in kilograms is how much of it there is. How much sugar have we got here? We've got a kilogram of sugar. If we had twice as much, would have 2 kilograms. If we had half as much, would have 500 grams. Yeah, so mass is measured in kilograms. It's how much of something that there is. For example, sugar. Now, what is its weight? Well, its weight is about 10 newtons, a little bit less than 10 newtons. Why? Because weight is a force, and it is the force due to gravity, usually due to the Earth's gravitational field. Okay, so weight is a force measured in newtons, and it is the force due to gravity. Mass, kilograms, weight, newtons. It's a little confusing when you ask your granny what her weight is, and she says, oh, it's 25 stone, 12 pounds. And it's a bit confusing because she's not a physicist. Okay, for a physicist, like your granddad, weight is measured in newtons. Here's a mass of 1 kilogram. This is probably what you will use in physics lessons. So a mass of 1 kilogram has a weight of about 10 newtons on Earth. That is a 100-gram mass on the right, and a 100-gram mass has a weight of about 1 newton. And that's about the mass of an apple is 100 grams. And interestingly, so 100 grams has a weight of about 1 newton. Bit like Isaac Newton, that, isn't it? Now, if you were on the surface of the moon, if I took my bag of sugar up to the moon, now, would it still have a mass of 1 kilogram? Would it still have a weight of 10 newtons? What do you think? Would it still have a mass of 1 kilogram? Well, the answer is yes. You've got the same amount of sugar. It's still a kilogram of sugar. We haven't used any of it up. Would its weight still be 10 newtons? And the answer is no. Its weight would actually be about 1.6 newtons. Why? Because the moon's gravitational field is weaker than the Earth's. Because the moon has a much smaller mass than the Earth, so the gravitational field it produces is weaker. So our 1 kilogram bag of sugar would have a weight of about 1.6 newtons. The weight of an object is directly proportional to its mass. Now, I've put this equation here because you need to know what that little fishy thing means there. And it means is directly proportional to. That's what it means. So its weight is directly proportional to its mass. If you double the mass, then the weight will double. If you have 3 times the mass, then the weight will be 3 times bigger. If you did a graph of the weight against the mass, if they are directly proportional, then you get a straight line. Okay, that's what that means, is directly proportional to. You can measure the weight of an object using this thing here called a spring balance, or a Newton meter is another name for it. Why? Because the extension of the spring is directly proportional to, we know what that means, to the force that is applied to it, so the weight hanging off it. Okay? So you can measure the weight of an object using a spring balance if it is calibrated. Now, how would you calibrate it? Well, a couple of things. First of all, if it's got nothing on it, then it should read 0. And usually there's a kind of a little screw at the top. If it's not reading 0 with nothing on, then you need to turn this screw so that it reads 0. Secondly, if you put 10 newtons on it, then it should read 10 newtons. And if it doesn't, then, well, with this type of spring balance, there's not a lot you can do. Put it in the bin. Gravitational field strength, I mentioned, is little g, and it's in newtons per kilogram. And to work out the weight of an object, it's its mass times little g. W equals mg. Weight equals mass times gravitational field strength. And you need to remember that equation. Add it to your list of equations to learn. Okay, add it to your flashcards of equations to learn. Let's have a go at these little sums. On the surface of the Earth, little g is 10 newtons per kilogram, a little bit less maybe. On the surface of the Moon, little g is 1.6 newtons per kilogram. On the surface of Jupiter, little g is 26 newtons per kilogram. You'll always be given a value for little g, by the way. Now, an astronaut has a mass of 80 kilograms. Now, what would his weight be on each of those, and whereabouts would he be weightless? So if you want to pause the video and work them out, I'll show you my answers in 3, 2, 1. Okay, so W equals mg, and you're just multiplying the mass 80 by the value of little g, and the answer is in newtons. Where would our astronaut be weightless? And the answer is in deep space. Okay, and deep space is basically millions and millions of miles away from everything, outside of the solar system, in between the galaxies, deep space, nowhere near anything, so that you're not in any gravitational field at all, and then you would be weightless. Okay, some people are a bit confused. They think, oh, if you go up in space, you're weightless because you're floating around. No, you're not weightless at all. You're in orbit, and we will discuss that in another video. Another thing about mass that you should know is this idea of the center of mass. Okay, when you draw the weight of an object as a single arrow, you're saying that it's all coming from one point, and that point is called the center of mass. So the center of mass is the point that you can consider all of the weight of an object to be coming from. That is the center of mass of the object. You know, this car, there's lots of different bits of the car, and each bit of the car has its own weight. But we're not going to draw, 1,000 different arrows coming down from the car. We're just going to draw one arrow, and that's for the whole thing, and that's coming from the center of mass of the car. Let's finish with a question. You are an astronaut that's just landed on a new planet. Describe how you might measure the gravitational field strength on the surface of the planet. So pause the video if you want to have a think about it. And the answer is that one way you could do it would be to use a 1 kilogram mass and a calibrated spring balance and hang it off there. And if the spring balance says 7 newtons, then little g is 7 newtons per kilogram.